Hi, Bronson. Good to see you. Hope you're having a good day. And it's very, very beautiful day out there, but chilly, chilly, chilly. I'm about 6 or 7 minutes early, so I'm gonna get started probably in about 4 or 5 minutes. But I want to make sure that I was online and the whole bit and ready to go. Well, I've got you on here. Any questions that I can answer for you? If you have any questions, there is a chat function so you can fire them to me. And those are invisible. If there's something I can share, I'm happy to say, here's the question I have to everybody. Or if not, I just simply look at the question and try to answer you. Anything? Okay, well, we'll get started here. It's 10:54 according to my computer. I'm also seeing 10:57 on the other machine over here. So I'm going to wait about a couple of minutes or so, maybe 3, and get started. Ayami, good to see you. And we're going to get started here in about a minute or two. I was a little bit early, and I hope you're having a great week. You have any questions that I might be able to try to answer for you at this point? Okay. Okay, I think probably I'll go ahead because we'll have some people join us, and that's okay. Let me just quickly refresh our memory in terms of where we are. On Monday, we started, of course, this is module 4. No, actually, no, this is module 5. Yeah, time flies. It's module 5. And I'd covered county, the data and development analysis, that process. I covered it last week and then a little bit on Monday, but I think I covered it pretty well. Foster and Gorman, those problems, those two cases, I had the key here for everybody to see, and we talked about that. And then I alerted everybody to these resources here on logistics and networking. logistics and network structures, and we talked about that. And then also this resource, some research studies on data and development analysis. And let's see who glad. And Tyler, glad to see you here too, as well. And again, as I'd mentioned at the end of that recording, that lecture, I was probably going to jump ahead to the cases for next week. And so I think I'm probably going to go ahead and do that. We've covered Foster and Gorman, and so this part of it's out of the way. So we have three cases, okay, and three cases and 3 exams, 4 exams coming up next week. Well, that's because of the spring break. So I had to kind of load everything in there. Now, to kind of keep everybody on an even keel, I've got the keys or explanations that I'll use for the cases here. And then you guys, of course, have the 4 exams or quizzes to worry about. So you're in pretty good shape. Now, I'm going to take a notepad here for just a minute. Let me do this. Let me copy this. I want to throw it on a little notepad. The cases we're going to look at are all over they're in the Anderson text in the chapter 7 of the student file. So let me make myself a note here for a moment. And pull this up here for just a sec. Some technical difficulties yesterday. It was the demons were running around going crazy. Okay. So I've got that on my text note, on my sticky, and that was at 11:23. Okay. Now, let's start with the very first case, and that's ice cold. And you really don't need to download anything. Well, I've got I have ice cold explained, RMC without the setup costs. This is a make or buy decision with setup costs, and then Martin Beck. And I want to alert you also, I have some, as usual, I have some very good resources here for you to take a look at. And I think you've heard me push this a lot. Logistics, transportation, there are jobs out there. Yes, that's a growth area. And I'll say it again. It's my belief that we're going to come to a point one day where the technologies will have matured and the tech companies and e-tailers and folks of that ilk will not have as much value as will the folks who get their goods and who get the goods from point A to point B. So I think many of these companies out here, that the money in Wall Street will eventually go to them, and they'll be very valuable. So I see some great opportunities out there for folks. And I have a link, 3 links, jobsandlogistics.com, careers in logistics and supply chain management, and then the Bureau of Labor Statistics, their data about logistics. And I'm just going to tell you this, they are always looking for people who are bright, who will work hard, and who are willing to learn. And with the background that we give you here with these technology courses, you are people they would be looking for. Now, I understand to say, I work for J&B, it was a trucking firm, a delivery firm. That doesn't sound really sexy. I understand that. However, there are great opportunities there. And I've shared that information with everybody in the last screencast. So, nonetheless, we're going to go over to and take a look in the text, and we're going to look at ice cold, and it's over in pages 328 to 330. So let me go back up into the textbook, and we'll go from there. I'm glad to see all of you here. I did get started a little early as usual, so if you want, you can you can double back and see the intro over at page 328. And it starts with linear programming. Okay. And here again, we talked about 0-1 variables. Now, you've heard me say many, many times that when we make a decision, that the outcomes are not binary. They are continuous. In other words, they run along a continuum, or you could say around the like the normal curve. But when we make a decision, it is a choice. And so 0-1 variables are binary variables. They're ones in which we either have a go or a no-go. We do it or we don't. And so we try to use optimization as a way to determine if we want to undertake a project or not. Now, I have a link over there on Capital Budgeting Explained, and I'm assuming that all of you have had a financial management course, Intro to Financial Management. That being said, you should have studied capital budgeting, at least in a cursory fashion, and you should have a pretty good grasp of the notion of sunk costs. That is, money that we have to spend up front, whether we make one additional product or make one additional sale. It's the money it's the skin we got to put up to get into the game, okay? So sunk costs are things we have to take into account in capital budgeting. Then in capital budgeting, we also have to take a look at the cash flows. And are they regular, like an annuity? Are they irregular? How far are we projecting? How confident are we of the cash flows, etc.? So we're going to see some applications here in capital budgeting. And here they start with Ice Cold, which is a refrigerant company. And this first table will give you an overview in terms of their present value in terms of their capital requirements. Now, if you see, of course, if you look at the chart, you'll start with they have the projects, they have the capital available, they have a capital budgeting situation, okay? And they have capital requirements for each of those products for each year, okay? And they have a budget. And here what they want to do is maximize the net present value of their projects. So you can see right here, and this is right now, here's the objective function subject to these following constraints. Okay, now, most companies operate under a condition of what we call capital rationing. That is, they only have so much money every year. And if it's a large firm or even a semi-large firm, or if it's a smart firm, they'll have some kind of capital budget committee or group who says, okay, here are the projects in which we can engage. Should we do them or not? So we're seeing that here with Ice Cold. Now, the authors also talk about fixed costs that come into play. And then they show us the solution for this problem. And here we see the different variables, their values, the constraint, and any slack or surplus. And they show us again here, here's the solution to RMC. But let's go back to Ice Cold for a moment and take a look at it, okay? So I'm going to go back over here and scroll down here, and this Ice Cold Explained, and we'll take a look at it. And in fact, I gave us some, I had some changes there, conditions. Let's take a look at it for just a minute. Yeah, you'll want to go ahead and download it to your desktop and then upload it for the ice cold case. Let's open this up here. Now, let me do this. And let's scroll over for just a minute. Now, I give you some instructions here. And what I ask you to do is in cell F20, enter a 1, and then see the new results in cell D16. So let's try that. So in C20, okay, let's scroll down to C20. We put in a 1, and then we see the results. This means we're going to go ahead and do the plant expansion. Let's see what happens if we put in a 0. How does that change things? And you can see the maximum net present value that we obtain. Now, I'm going to pop that back for a moment. And of course, I'm going to open up data, and we're going to go take a look at Solver. And this should be familiar to us now. We're trying to maximize the net present value. As a refresher, the net present value represents how much in today's dollars future dollars are. We want to know what the money that I'm going to earn in the future, what would it buy me today? And we use that present value as a way to assess whether or not we want to do a project. Now, we've got some changing cells, and of course that's C20 through F20, and that's those choices. And remember, if it's a go, it's a 1. If it's a no-go, it's a 0. And then we have it subject to the constraints, and we're still assuming a simplex LP. Okay? Now, I also ask you to play around with a 0 for new machinery. Look at the conformance of the left hand and right hand side. And as we talk about that, we say, okay, why new machinery and new product research? Why would I perform those? Well, why would I defer on them? They have the lowest NPV. So the beauty of this is that you can, if you wish, take a look at these scenarios and come up with, based on available capital and the net present value each year, what you want to do. That's the whole point. Now, you say, okay, are you going to give me the standard sermon about these better be good numbers? Yes, I am. If they're not good numbers, they won't float. For about 10 years, I worked as a consultant with a firm that did mergers and acquisitions. So I understand capital budgeting quite well. I was with a team that did the cash flow analysis, which was the most critical part. And in that, what you try to figure out is, if these two companies come together, will they generate the cash flow sufficient to give somebody a payday? And that somebody is typically either the firm, it's typically the firm that's being acquired, the target firm. They want to pay out, they want a payday. And so you might borrow a bunch of money and buy them. So if you do, and then you begin to operate, you got to make sure you want to do the best you can to figure out, are we going to get a return on the investment? So for all intents and purposes, when you're doing those projections, they'd better be based on some type of reality. And one of the things that, as I was making my exit that we did, and I've shared this with all of you before, is that Excel spreadsheets were really starting to come into their own, and we would run projections. We would do, we give them summary data from, say, 1,000 simulations, sets of simulated data using the random function, and tell them, okay, well, here it looks like a reasonable range, and give them a summary figure and let them plug it in. Nonetheless, it was never entirely accurate. In some situations, we were way off, and that was probably due, as we went back and constructed those, was due to industry conditions changing, a disruptive innovator who entered the market, or that type of thing. But it was an interesting experience, to say the least. So we had to make sure we had good data. So that's my have good data sermon. But this is a nice exercise for you. Okay, to take a look at each of these and plug in a go or a no-go, see what it looks like in terms of maximum net, see to the extent to which you maximize your net present value based on the constraints that you have. So that's ice cold, and that's pretty cursory, but it's covered there, pages 328 through 330 in your textbook. And you can upload the file for the credit, but I certainly have an expectation that you're going to take a look at the text and you're going to go through it. Now, I am aware that we've jumped ahead. So Monday we'll be in this module anyway, but I certainly want you to take a look at that process as they discuss it there, especially the variables, the value, and the constraints, and any slack or surplus we have in those constraints. And you can see we've got considerable surplus in constraint 2 and in constraint 3. So it's sending us a message. Now, again, this is one of those issues where you really better be sure when you start doing those net present value figures that you've got good numbers. And you also need to ask yourself, are these the right projects? When I was working on my master's degree, a long time in finance, a long time ago, I was lucky to have 2 instructors. One was a gentleman who wrote the book, basically wrote the gold standard textbook exclusively on capital budgeting. I had 2 courses in it. The second course was taught by a gentleman who was with, at that time, Southwestern Bell, and he was their head of their capital budgeting unit. So he knew capital budgeting inside out. And I know you think I torture you, etc. But if you recall from Intro to Finance, one of the funnest things you ever get to do is the internal rate of return. I can see you already holding up the garlic to ward off internal rate of return. If it will help you feel any better about the experience you have with me, trust me, I was tortured because I got to go take exams where we did the internal rate of revenue by hand. There was no IR function that we could use in Excel to run to get that. We had to do it by hand. We had many of those, all of them were by hand. And then near the end of the course, the instructor decided to let us use, laptops were still kind of new at that point, but our instructor said if you have a laptop, bring one, or you can go down to the lab. They had a lab there. It was at Webster University there in St. Louis. Excellent school. And you can use the software in the lab. So as I was running IRRs, I got pretty ticked off because I'm going, wait a minute, I've been doing this stuff by hand. If you've done IRR, you know it's an iterative process and it is about as tedious as it gets. Well, that being said, we've done a pretty good of looking at that. And again, we're working in a capital budgeting environment where it looks like to me, and I can't remember if the author said it, but I would assess that what these are mutually exclusive projects, meaning they're not interconnected. They're all independent. So if I choose not to do one, it really won't have much to do with the others. However, I look at something, say, for example, like new product research, and I would say, well, okay, maybe that. New machinery, possible, okay? But the plant, the two expansion options, the plant and the warehouse, are definitely interconnected. And I've said it before many, many times. Every square foot in any business facility is precious. It's got to be productive. The hallways, they eat up money. They cost you money. But offices, laboratories, warehouses for inventory, receiving stations for inbound, outbound stations, parking lots, that all has to be figured in. It has to be paid for. Now, I'm conscious of it because I grew up with a father who was an entrepreneur who was in the grocery business, then later into strip malls, and he understood every square foot of that store's got to be used. And so he was one of those people. He probably ran one of the first big box stores that people have ever had. He had certain goods in one part of his store that were palletized, just like you'd go to Sam's. And I laugh when I go to Sam's because my dad was doing that in the 1960s. And these people are doing it today. That being said, again, the nuances of capital budgeting are kind of glossed over here, and that's okay because the authors want to let you see we can use the model to work with that problem, okay? Let's move on now to the next problem, and that one's going to be very easy for us to get to, and that's going to be the issue that faces RMC. And this is a company that uses 3 materials, okay, to produce some products. They use raw materials to produce 3 products. This is a load balancing type of problem, okay? Whether you're talking about stuff flowing into a workstation, say components, parts of a component, or you're talking about moving fuel and solvents and carpet cleaning, producing those. You're talking about load balancing. And I probably told the story, but I will very quickly again. One of the most fascinating experiences I ever had was to tour the Anheuser-Busch brewery in St. Louis. At the time, AB had not sold its, was still, I think they had just gone public, but it was still very closely held by the Busch family. But it was fascinating because as we went through the tour, we went through the area where they had the vats that moved the product. And they had people who would descend into the vat, and they'd be wearing this surgical lint-free gown with these gloves, and they had special polishing cloths and they would polish the inside of those. Yeah, they polished the inside of those, and as they did, they were making sure that they reduced the drag or the on the flow of product as it went through them, because any drag on that volume, on that much volume of liquid, cost money, and so they're very conscious of that. And so as they moved it through those vats, they wanted those vats as smooth as they could possibly get. And I thought, well, that'd be a creepy job, because if somebody accidentally hit the lever and started pushing liquid through there, you're in there. And they would lower themselves down on a special rope, and when they were finished, someone would haul them back up. And they had to do that, and they had to do that to ensure that they kept their costs down, because they're moving so much liquid through those vats. It was and I thought would be an interesting thing to mention to you, since we're talking about moving material. And so we have a maximization function, okay? And here then we have our we have the constraints, and that is the load of how much we're going to make. Now they show us the value over here, the solution to the problem. So let's go back over here, and we'll take a look at, we'll go back over to the module. And we're going to look at RMC. And you're going to see two files. Now you can upload either one of these files, okay? Either one. This is RMC without the setup costs. Now, as the authors talk about, this company has to be mindful of the fact that they have setup costs if they decide to do some batch processing. Okay? If they decide not to, see, again, this is one of these binary choices, and they're trying to figure out, okay, do we do it with or without the setup costs, and how do we absorb it? And this is with the setup costs. Let's open, and I'm going to go back again, and let's get that file. So we'll get RMC without the setup costs. I'll start with it. Okay. Now, I show you the net profit per ton that's produced for each of the additives. And I give you some coaching here in terms of what you'll see with pages 326 and 327. And that should be objective function, not objective. And the value per variable. Now we see how setup costs impact this maximum net profit. So we see that the tons and the amount available and the profit. And so we're trying to maximize net profit. Again, a binary approach. Do we want the setup costs or not? And I note to you that the setup costs reduce the net profit. Any batch manufacturer, let me stop for a moment. There are two types of manufacturers. One of them is what we call a continuous. A good example would be utility companies. They produce electricity on a continuous basis unless it's disrupted by a storm or something like that. Auto manufacturers within a given brand and model run a continuous assembly line. The airlines operate as a continuous service facility. They're running all the time, 24 hours a day, 7 days a week. Water systems. And so when you have that type of environment, it's very different from the challenges faced by what we call a batch producer. A company that sells stuff for a limited amount of time. A food truck is a batch operation. They're there for so many hours. They sell certain products, so they're there and then they're gone. They're not operating 24 hours a day. The Walmart operates 24 hours a day, primarily for one reason. They need to get every dollar out of every square foot they have. So they are a continuous operation. But batch operations would be like if you ever see on cable these people out in California that they take somebody's car and customize it, make it really cool. That's a batch operation. A bakery that they'll have certain goods they make so that they sell every day, but their batch operation really amounts to when they take orders for cakes, or orders for weddings or catering or stuff like that. And to do setup costs money. It's expensive. If you're talking about making cars, it can be very expensive to set up the manufacturing line to accommodate it. And that's why so many today, cars tend to be subsourced by basically the same sources. And then there are some differences in them in terms of branding. But your basic automobile, the basic components of an automobile are manufactured on a continuous basis, and then the batch operation comes when the thing is customized for a particular brand, or you upgrade materials, or you upgrade components, the engine, suspension, stuff like that. Okay, so we're looking at this, and we see the setup costs reduce product and reduce the profit. And it is difficult to do that. And again, the airlines have an advantage over delivery companies that are ground-based. Airlines fly from point A to point B. So FedEx Air, for example, or UPS Air, for example, have it much easier than their ground-based affiliates, for the simple reason the ground-based becomes the nightmare of getting it from house to house to house to house. Yeah, UPS doesn't call your house and go, hey, we have everybody's junk over here at May and 39th. Come get it. It's going to come to that one of these days. I've got a hunch that one of these days somebody's going to say, let's just put a storage locker out there and somebody with it. And when a client arrives, they pick their stuff up. So UPS calls you. It'd be easier for them to do that than to send a truck and have a person jump off and run up to your door and have you sign for it. It's dramatic, Okay, and they try to put a little drama into all that. FedEx does the same thing too, to give you that hype of, hey, we're pushing through and we just got your stuff here. But my hunch is that one of these days there's going to be somebody out there who's going to say, why don't we just put these in a centralized location, tell everybody within a 5-mile radius, we've got your books from Amazon, bring in this number with your receipt, come pick it up. They're here for you to get them when you want to. And then you sign for them there. My hunch would be that probably there's going to be probably a Walmart or somebody like this, or some of these malls that are emptying out. Someone's going to say, well, let's try that. It may be going on in some parts of somewhere on a consumer basis. On a on a commercial basis, it goes on all the time. The railroads are a favorite source, a place by which companies inventory, store a lot of inventory. If it's not perishable and you want to do a continuous production run for 2 months, you do that. Then you load everything on a train and you send the train to the city where you want it to be. But then you may have probably a place. It's usually going to be a place with a large railroad yard where you can safely just let them sit. Now they don't do that with automobiles, but there are many, many products that you'll see that they'll do that simply because they just use the railroad as this place to store their goods. So that setup cost is a challenge, and RMC deals with that issue. And we can see that when we get some differences in the net profit. And notice how much the net profit decreases when we have the setup costs. And this illustrates that. Well, I have another file there for RMC, and I'm going to close this one off. And let's go back to the module. Let's scroll on down, and we have RMC, okay. And here it is with the setup costs. And the text gives you the narrative for this. And we'll come back and visit a little bit so we can get some more out of it. But notice here we are, we've got the maximum, we're trying to maximize the net profit. And here are the additives, the tons available, the profit per ton, the setup cost, and the capacity. Of course, the constraints. And as we saw in the first one, without the setup costs, it's about 500 less. Let's call these thousands of dollars, 500,000 less than it does with the setup costs. So we gain in our profit, we gain in our net profit, which we're trying to maximize. Now, you say, okay, I get that. What's the point? Well, here's the point. You say, well, okay, Dr. Harmon, how would we reduce setup costs? This is a management science course, so we're talking about optimization, but a piece of this is understanding the environment in which that occurs. One of the ways that you deal with the issue of setup costs is that you just simply try to design components that are as ubiquitous as possible. You said, what in the world are you talking about? Let's take the brakes on a car. The braking pads, the braking system is pretty fragile compared to the rest of a vehicle, and has some delicate and pretty it has some fairly daunting engineering challenges because you're creating a device that will stop a 2-ton piece of metal or alloy traveling at 70 miles an hour. You don't want the brakes to fail. So people who make brakes will try as much as they can to defer the issue, to handle costs imposed by setup costs by standardizing brakes, designing them and making them in a standard way so they will fit on a vehicle or be installed on a vehicle in the manufacturing process so that you can sell your brakes to anybody you want to. You may have some minor modifications. You may have some different qualities and the type of brakes, their capabilities, but for all intents and purposes, you have a long continuous run. Now, a continuous run may mean you make brakes for 2 months, okay? And then you ship the stuff, or maybe you store it and then ship, and then while you're selling off the brake inventory you've created, you make something else. Most batch manufacturers or manufacturers of components, especially things like automobiles, do so. They just flip from one thing to the next and then follow that cycle back. So the design and engineering of them, the more uniform it becomes, the better off it is for those manufacturers. And that's hard for the public to register with, because so much of advertising of automobiles is image and lifestyle and stuff that has nothing to do with the vehicle. Now, I mean, when you see an advertisement for Ram trucks, for Dodge Ram trucks, I mean, hey, you don't go, well, what's the torque? They'll say, I think it's they or Ford say we set the bar. And I love to watch those because you have them towing airplanes and all kinds of crazy stuff. You don't get much in the way of statistics or anything like that. Primarily because they're in many ways they're selling you the same product. It's packaged differently. The frames, the bodies are different. They have a Ford versus Chevy, but the essentials of that vehicle itself are not too different, because the people who make, for example, brakes, the people who make transmissions, the people who make suspension systems could not stay in business if everybody wanted their own thing. There was a day and time in this country at the start of the automobile age, I would call it that, where I think we had at one point and I'm probably wrong, but I think it was thousands of automobile manufacturers, if you can imagine that. And then it got winnowed down, and finally we ended up with the so-called Big Three in the United States. But it was not uncommon for you to have 5 or 6 different manufacturers. Well, after a while, they learned about economies of scale and those issues. So setup costs deal with those. If you have a good economy of scale, then you can lower your setup costs. And the two of those really operate in an inverse basis. Okay? It's the same thing with foods or anything of that nature. And again, I always like to tell you stories from my experiences, because I feel like that, having lived through a lot of this stuff or seen it or observed it, the 10 years I worked as a consultant, it was an eye-opener. We worked with so many different kinds of businesses, primarily financial institutions. But we really had to we really had to wrap our heads around many of the firms they serviced and took care of and their customers, because ultimately that merger or acquisition will not work if people stop buying or stop using the service of the new entity. But one of the things that just fascinates me, is that issue of of setup costs versus a continuous run. And the dream is to be able to do a continuous run, sell everything, to make sure you don't make too much. And that's where you get into the economic order quantity and having to be careful about things like the bullwhip effect. Very, very interesting stuff and challenging stuff. So again, here we have this situation where we have with the setup costs, and notice our maximum profits were pretty low. So manufacturers try to defer as much as possible setup costs. Now, this is interestingly, this is something that has bled itself over into the world of medicine and healthcare. It used to be that hospitals were competing with each other. Now it's, I'm the heart hospital. If you've got heart problems, I'm the place to come. Go nowhere else. Why? Because they have said, okay, we're going to operate in a niche, and we're going to avoid and we're going to handle the setup cost. The very, very sophisticated and expensive equipment that they use, say at the Oklahoma Heart Hospital, you're not going to find it in the general run-of-the-mill hospital down here. They'll send you over there. It's the same with cancer treatment centers. That cancer treatment center was probably the very first cancer treatment centers in America. They're a franchise, and they treat people with cancer. And they use a whole array of processes and techniques. And some friends of ours at church, a lady was one of their clients, and as she shared with us how they worked with her, I thought it was amazing. She was not treated like she was on a conveyor belt, and here's what we do. Everything was tailored to her. Now, they probably had 1,000 of her all over, and so things were pretty standardized. But the equipment and the cost and all that business, I would say probably another place, say up in Oklahoma City, would be the Harold Hamm Diabetes Center. They have all kinds of equipment, highly specialized physicians who do nothing but work with that disease. So again, hospitals face this. One of their biggest challenges is the emergency room. Emergency room care for hospitals is an enormously challenging proposition because you don't know what's coming in the door. And there's no way for a GP to get any better training than to work the emergency room. And a good friend of mine who's a doctor up in Stillwater, he started in the emergency room, and said, this is great training for me to become a general practitioner for the simple reason you learn how to diagnose stuff, and then you learn how to take patients and funnel them off to whatever specialization they may need, or how to handle problems and talk people through them if the condition is not, it's something that someone's been hurt and what do I have to do the next 3 days and all that business. Setup costs are part of the issue. Universities face that. A big cost for a university is dormitories, is a rock, a facility like the Rock, the Geiger Center, a place for all of you to come and buy coffee or whatever you're going to do. Classroom space. You'll notice there in Bailey Business Center, if you walk around. Now, first of all, if you think of the Bailey Business Center, the Bailey family, thank God for their generosity. What beautiful people they were. And if you walk around that building, I want you as a business student, every time you're in that building, I want you to look at those plaques on those walls and say a prayer of thank you, because those people put the money up to pay for that piece of the building. And we are very fortunate. Many of us, maybe you're aware or not, are endowed, have endowed professorships. And those families who gave the funds to endow those professorships, all of us who have them are extraordinarily thankful for the generosity of those people. Tremendously generous people. And often it's the difference between someone could come here at all or not. So, and then each spring, I sit with our faculty and we go through the process of giving out scholarships. Our business college gives out tons and tons of scholarships. And I want to say this, I get very upset when someone receives a scholarship and they're not there to get it. So if you find out that you're going to be getting a scholarship, show up. I think it's awful that we'll award people scholarships and they don't show up. The families who gave that money, the businesses who donated that money, did so out of the generosity of their heart to provide and support. And it makes me cringe when someone gets a scholarship and they're not there. So please be mindful of that. We'll be doing that this year. And so as I've watched over the years, I've become it's a very humbling experience to walk in that building and to see how many people have made it possible for OBU to have a business school and have the kind of business school it does. We've got a good school. We have an outstanding school. We send graduates out who are high performers, have great ethics, great attitudes. I'll put you guys up against anybody in the world. In fact, back when I taught the policy course and I would use the simulation, I would pit our students' teams against teams from some of the finest schools in the world. And our OBU students did very, very well. They were usually in the 80th or 90th percentile. They'd run a company and they'd be ranked in terms of their operating results. And I would regularly have at least one or two teams in the 80th or 90th percentile. And when I'm talking about versus teams of students from some of the big name schools in the United States and around the world, that says something about you, okay? And the investment that we put in. Well, as I said before, we'll take a look at, I've jumped ahead a week, so on Monday, we'll continue on looking at this some more with these setup costs and these binary types of decisions, and we'll talk about them. And of course, you have some exams are due. And I think next week, and I think then 2 weeks from now will be spring break. Folks, thank you so much for being here. Appreciate it. And let me stop. Is there anybody that has a question I can help you with? Anybody? Okay, if not, then I will see all of you Monday. Have a great weekend.